Welcome to This Explainer. Today we're joining two friends, Leo and Maya, on a pretty epic quest. They are trying to map out their entire neighborhood using, of all things, the secrets of geometry. Now I know that might sound like a massive, complicated task, but as you'll see, the basic building blocks of geometry are actually the absolute perfect tools for the job.
Okay, let's dive right into this map-making mission. We're going to see how really simple math concepts are essentially the ultimate survival tools for navigating the real world. Imagine you're right back in the 6th grade. You're standing in your neighborhood, and you're holding a completely blank sheet of paper. How do you even start making sense of the giant space around you? Well, that is exactly the challenge Leo and Maya are facing. They need a system, a way to translate this huge 3D world into simple marks on a flat 2D page.
Section 1. Connecting the dots. Because every great map has to start somewhere, right? Let's take a look at the very first element they need to drop onto their paper.
For Leo and Maya, their treehouse is the ultimate landmark. So on their map, this becomes a point. Imagine taking the sharpest pencil you own and pressing the tip right onto the paper. That tiny little dot gives you the basic idea of a point. It determines a precise location, but here's the crazy part. It actually has absolutely zero length, breadth, or height. It's kind of a mind bender, but you just have to imagine it as being invisibly thin. And to keep things organized, our mapmakers label this point with a single capital letter, like P for treehouse.
Now notice the huge difference here between a real-world path and a purely geometric idea. When Leo and Maya walk from their home to the treehouse, they're traveling along what we call a line segment. That's just the shortest route between two distinct endpoints. But a true geometric line? Well, a line passes through those 2 points and just keeps on going. It literally extends forever in both directions, right off the edge of the paper. Since there's absolutely no way they can draw a line that goes on forever, they use the line segment to represent their actual walkable path.
Section 2. To infinity and beyond. So what happens when Leo and Maya need to look out into the dark, uncharted areas right past the edge of their map?
The crucial thing here is that they need a brand new geometric tool, something to describe a path that has a start but absolutely no end. Enter the ray. A ray is just a portion of a line that starts at one specific spot, we call that the initial point, and travels infinitely in just one single direction. It doesn't go backwards, only forwards, endlessly. And honestly, this brilliantly illustrates a real-world ray, a lighthouse that they draw on the coast of their map. Just think about how a lighthouse actually works. The bulb inside the tower? That's your specific starting point. From there, it shoots this single, powerful beam of light out across the dark ocean. That beam goes on and on in one direction, slicing through the night. It's literally the perfect model for a ray.
And we see this exact same concept right in Leo and Maya's hands. It's just like the flashlight they use to guide their way down a dark, spooky path. The bulb of the flashlight is the initial point, and the beam of light pushes forward endlessly into the dark. By understanding rays, they can map out the direction they need to explore next, even if they have zero clue where the path actually ends.
Moving on to Section 3, taking a turn. Because as our friends navigate their neighborhood, they realize pretty quickly that straight paths eventually cross and roads eventually turn. You simply can't walk in a straight line forever. This brings us to a massively important concept. When two paths, or hey, let's call them rays now, share a single common starting point, they create an angle. Think of a street intersection on their map. The angle isn't just the physical corner itself. It actually represents the amount of rotation or the turn between those two diverging paths. To really wrap their heads around an angle on their map, they follow 3 super simple steps. First, locate the hinge, or the common starting point. In geometry terms, we call this the vertex. Step 2, trace the 2 rays branching out from that vertex. We call these guys the arms of the angle. And finally, step 3 is looking at the actual size of the angle, which is entirely based on the amount of turn you'd need to move from one arm over to the other.
You can actually see this geometry perfectly in a common drawing compass or a divider, exactly like the ones Leo and Maya keep in their mapmaking kit. That top hinge, where the tool pivots, that's exactly what we mean by the vertex. And the 2 pointy legs that you pull apart, those act as the arms of the angle. It's simple. The wider you open the compass, the larger the amount of turn, and boom, the bigger the angle becomes.
Section 4. Angles all around us. As Leo and Maya take a breather to unpack their survival gear and review the map, they realize something pretty cool.
These geometric shapes aren't just boring lines on a piece of paper, they're hiding right in plain sight, everywhere around them.
For instance, if you wear glasses, you actually carry angles around with you all day long. As you fold the arms of your spectacles out from the main frame to put them on your face, those tiny hinges act as vertices. The frame is one arm, the earpiece is the second arm, and the rotation at that hinge forms perfect, everyday angles.
It really is everywhere. Whether Maya is flipping open her wallet to check her pocket money, or Leo is lifting the flap of a cardboard box to grab a quick snack, geometry is happening. Notice how the amount of rotation at the hinge creates completely different sized angles. If you barely open the box, that creates a small turn, which means a small angle. But flinging the wallet wide open, that creates a much larger amount of rotation and a way bigger angle. Now here is a fantastic map maker's secret. What if Leo and Maya ever need to figure out which angle is bigger on their map? Say they want to compare the turn of Oak Street to the turn of Maple Drive, but they don't have a protractor or any measuring tools. Well, they can use a neat trick called superimposition. Honestly, it's just a fancy word that simply means placing one angle directly on top of the other. The key step is making sure their vertices overlap perfectly and at least one of their arms aligns. Once they do that, it's instantly clear which second arm sticks out further. The one with more rotation is the larger angle. It's a quick, visual way to solve a math problem right out there in the field.
So we've traveled from an invisibly tiny point all the way to infinite rays, and finally to the turning angles that literally build the world around us. Now that Leo and Maya have the basic geometric tools to map out their neighborhood, I have a challenge for you. Take a quick look around your own room right now. From an open door, to the hands of a clock, to the corner of your desk. What is the absolute largest angle you can spot hiding right near you? Keep your eyes peeled, because geometry is everywhere. Thanks so much for joining me on this explainer, and hey, happy mapping!